Hello friends, welcome to Physics with Ben. In today's video I want us to have an overview of how this year's Waec Physics 3 experiment looks like. I haven't waited this long and I haven't consulted with some of my colleagues. I have to come up with this to give the teachers and the students of physics an overview of Waec 2023 exam, practical exams. Disclaimer, this is not your real Waec exams. Waec will not bring exactly what you are seeing here on the D-Day of the exams. But this exam will give you an overview of how the exams will look like. It will interest you to know that I have performed experiments on potentiometer and also theories on potentiometer and Wheatstone bridge, meter bridge. You will love to click in the description box of this video you are watching and have access to all of that. I have come here not to run experiments in details I've been doing, but to give you some spotlights as a teacher, as a student, where to pay much attention to. So the first things first we are going to do is to connect the circuit diagram. Okay? We have the ammeter. This is our ammeter. I have taught us how to use the ammeter. So click the description box below and you'll see the video on how to use the ammeter. This is the ammeter here, and then we have the cell. This is a cell. We have the rheostat. This is the rheostat. We have the voltmeter. This is the voltmeter. We have the variable resistor, the resistance box. And then we have the standard resistor, 1 ohm or 2 ohm, whatever. That's it. So it will also interest you to know that the examiners made mention of something like this, the meter bridge. The meter bridge is always used alongside with the galvanometer, and the galvanometer was not mentioned in the practical guidelines for physics this year. So we are not going to use the meter bridge because the meter bridge does two work. It does the work of the potentiometer, and so we are going to put this guy aside. We look at this guy as a destructor. So let's connect our circuit diagram. So right here is PQ, our potentiometer is here right now, and our ammeter will be placed here. Battery, in this case I just wrote it as a cell. This is the plus side. Let me increase it. Yeah, this is negative side. So this is our cell or the battery. I place it here. This is the plus side. This is the plus side here. I place it here. And this is my rheostat. And then so let's do the connection. Yeah, my variable resistor is here. My voltmeter is here. So the voltmeter will be connected across this. Now let me tell you what will happen here. The potentiometer and the rheostats, the resistance box, they are all examples of variable resistors. They do the work of varying the voltage and the currents in the circuits. So what we are supposing from our discussion as physics teachers is that there may be a place where we are going to connect the potentiometer and then the voltmeter across the potentiometer, because the voltmeter is always connected across a resistor, and in this case the potentiometer is a variable resistor. So the voltmeter will be connected across this, and then we'll vary the length and then know what happens to the current and then to the voltage. We may choose to connect a standard resistor in this place, which is what you see here, and then connect the voltmeter across the standard resistor. We may also choose to remove that, connect a variable resistor in between here, and then a voltmeter across the variable resistor. Is that understood? So, without wasting more time, let us connect our circuit diagram. So this is, let's connect it anti-clockwise. So we start with this. One leg connected to the negative side of the ammeter, and then to this place. From use the red side for positive side, and then from the positive side to the rheostat, the positive side of the battery to the rheostat, to this end, and then this is the slider, the rheostat back to P. This is our P to the potentiometer. So this leg here, make sure your connection is tight, good, to this place, and then we connect our voltmeter. Our voltmeter across the potentiometer. This is it. The voltmeter across the potentiometer, and one leg of it back to this place. Good. So let us connect the right hand side of the circuit. So one leg the right side to this. We're using 0 to 3 ohm, and then from here to the key. This is the key. And then from the key is open, so I open the key. From the key to Q, so I just use red. From the key to Q. Good. So I told us this place is where we may be connecting. So let me just connect this here. So in this particular region, we may choose to remove this and put it here. We may choose to remove this and put this in between here. So what I'm trying to say is that this guy, and this guy, this is their position here. And this guy is across all of them. Let's look at the circuit if it is perfectly connected. So let me make my circuit and see the reading. Okay, this one is going this way, so I'll have to interchange the polarities. Take it closer. Pause. So you know when your circuit is correct when all the ammeter, the voltmeter are reading clockwise. You can see that the ammeter is reading clockwise, while the voltmeter is reading anti-clockwise. So we just interswitch this, and then we'll solve that puzzle. Good. So the voltmeter is reading clockwise and the ammeter is also reading clockwise. Everything is perfect now. Good. Next up, there's a small arrow here that stands for the jockey, and this is our jockey. We connect it here to vary the length of the resistance. So the jockey is also connected here, and this is the jockey. This part here, this is the jockey. So we'll keep it aside. Next up, we are going to connect. So we connect this here and then back to this. We keep it here. Then another leg from here to here. Mind you, this is on 0, 0, 0, 0 ohm. This is 0, 0, 0, 0 ohm. 1,000, 100, tens, and units. So it is on 0, 0 ohm. We leave it where we want to use it. So the voltmeter is across the variable resistor. The voltmeter is across the potentiometer. And if we still want, I can still connect the standard resistor in between. So before we proceed, I want to tell the physics teachers and students something. Sometimes it is very, very difficult to observe the change or the variation in current. So in place of the analog ammeter, in case of the analog ammeter, you can equally use a digital ammeter to get your accurate results when you have very, very minimal changes that can be hardly detected by this. And what I advise students is that on the D-day of the exam, if the ammeter, the analog ammeter is not giving you what you are looking for, please go for this. So this is the digital ammeter. We put it in place here in case we are finding it difficult to get our readings. We will just quickly hit a switch and connect this here and then connect this here to stand by. And then the digital voltmeter, in case this guy is not behaving well, we quickly replace it here and then get our readings done. Explanation of the theory behind this experiment. Remember, I have done videos on the factors affecting the resistance of a wire. As a student, what do you expect to know in this experiment before you go in for it? As a physics teacher, what do you expect to know? What are you supposed to teach your students? If you don't understand the theory and the equations behind the experiment that you are doing, you will fumble in the experiment. In every experiment, the theory, the equations, and the practicals must be saying one thing. There is a particular equation that controls the whole of this experiment. And that equation is given as R is equal to rho L all over A. Why R stands for the resistance of the wire, the resistance in the circuit. Rho stands for the resistivity in this connection of the wire, this length of the wire here. L stands for the length of the wire. And A stands for the cross-sectional area of the wire. Now for all these arrangements, we have the ammeter represented. We have the voltmeter represented. We have the potentiometer with the length and its area. So the equation that is controlling all of these variables is this particular equation. V all over I is equal to rho L all over A. V for the voltage, I for the current, and the L for the length, and rho for the resistivity of the wire, and then A for the cross-sectional area of the wire. Having known the theory, what relationship does this variable, this parameter share? it will interest you to know that V and L have a direct relationship. So in this experiment, if you keep this constant and decide to vary the length and the voltage will have a direct relationship. That is, as you are increasing the length of the wire, you are going to increase the voltage. So it is increase. And if you're going to plot a graph of V against L or L against V or V against L, you're going to have a straight line graph passing through the origin. Similarly, V, L and I have an inverse relationship. Meaning as you are varying L, I will be decreasing. In this case, this length of the wire also stands for the variable resistor. If you vary this guy and vary this guy, you are still going to have a decrease in current. If you vary this guy and vary this guy, you're going to have an increase or decrease in this. That is increase. Is that understood? So this is the theory behind the experiment. Next up, table of values or the observations. Why do we have the rheostats in this experiment? I told us that the rheostats, the resistance box, and the potentiometer, they are all examples of variable resistor. So why then do we have this guy here? The rheostat is here for us to get the peak value of the current and then the peak voltage of the current. And so we have to record the peak I here and the peak V there. That's all. And when we are done, we'll now face this experiment from this end. So in this experiment, your table of values carries the highest mark, as I've been saying before. So this stands for the EMF, and this is 1.5, 1.5. That will give you 3 volts. So you record 3. You record 3.00 volts. It's a constant. So you record all your constant on the top of the table of values. Next up, we want to slide the rheostat to get our peak I and then our peak V. So I'm going to connect the circuits. Right now, the jockey is here. This guy is on 000 ohm, and this guy too is on 0 length resistance. So the only thing that will be active here will be the rheostat. So I'm going to make my circuits. Good. So I'll slide the rheostat, and then you observe what will happen here. You observe something until you get the maximum value, then you stop. I am sliding it to the right, hands to the right. What do you see? Take this as well. And then I slide it this side. So I got my peak current when the rheostat was good. Got my peak current when the rheostat was at this position. Our V is on, this is 5, 6. Our current is on 1, 2, 3, 4, 5. 5, good. So you remember what I told you how to make use of the ammeter? We are making use of this and this. So we make use of the up calibration. How do you get it? 0.2 divided by 10 times 5 will give you the value for the peak current. And down here, what we have is 1 divided by 10 times 6 will give you the value for the peak voltage. Based on what I just told us, our peak current is 0.10 amps. Always record to 2 decimal places. And our peak voltage is 0.10 0.60 volts. So this is how your table of values will look like. You have the length will be varied. Maybe 20. I don't know how the exam will look on that day, but this is how it will look like. Maybe the length you start from 30.00 cm, 40.00 cm, 50.00 cm. That is if they want us to vary the length on that day. I've produced videos on how to use the jockey. So click the description box on this video you're watching below and you see all of that. This is how to do it. You place it around and then you see what happens to the current and to the voltage. You can see that. So that is that. That is you are varying the length. But if the examiners will not want us to vary the length but to vary R, what will you do? You put it aside and you start. This is 0 ohm. So this is 1 ohm, 1.00 ohm, 2.00 ohm. You can observe that the current is, just observe something. This is 1 ohm. The voltmeter is going this way. The current is coming this way, going this way. The voltmeter is reading clockwise, while the ammeter is reading what? Anti-clockwise. 2 ohm, 3 ohm, 4.00 ohm, 5.00 ohm, 6.00 ohm, 7, 8, 9, and 10. You can see that obvious increase. Increase, decrease, increase, decrease. So that is what will happen should you be asked to vary this. You may be asked to put this guy, this standard resistor, as a constant. This is a position. And then vary just this guy. Vary this guy. So this is what you need to know about the experiment. So you have your composite parameters. You have the length in cm, the resistance in ohm, the volts in volts. They may ask you to find V inverse, current, then I inverse. You must record this column and this column, V inverse and I inverse, to 3 decimal places, while this to 2 decimal places. So this is what you need to know about the experiment. In conclusion, examiners will always ask you the precautions you took while performing experiments. I'm trying to bring our attention to the spotlights in this experiment. I've done so much experiment on my YouTube channel. You may love to click in the description box below and watch all the videos. So I have already done this one before. I don't need to go back and do it again. That's why I'm saying all this. In conclusion, the examiners may ask you to state the precautions you took to get accurate results. Because you are making use of the voltmeter, the ammeter, and the potentiometer, you may state a precaution like this. I avoided error due to parallax when taking reading on the ammeter, voltmeter, and potentiometer. Number 2, I ensured tight connection. Number 3, I ensured the circuit was open when not taking reading. These are the 3 main precautions in electricity. Question number 3. Choose only 2 because they carry just 2 marks. Sorry, they carry 2 marks. Now, the next thing you need to know is in the BI and the BII parts. This is current electricity. Examiners may ask you to state Ohm's law. So you need to study how to state Ohm's law. Examiners may ask you to list the factors affecting the resistance of a wire. Examiners may give you equations to solve and a problem to solve where you have to make use of this set of equations. So as a wise student, while preparing for these exams, you have to look at theory questions on calculations that relate with this. Examiners may ask you so many questions around potentiometer, Wheatstone bridge, meter bridge. So this is that for electricity. Next up, I will do an overview, a video on optics, what you need to know about this experiment before you go inside it, and then next up, a video on question number 1. So to this we have come to the end of the video on current electricity. To this we have come to the end of the overview on question number 3, current electricity. Next up, optics and mechanics. Thank you. God bless you. Don't forget to subscribe, like, comment, and share. Bye-bye.